Hi and welcome once again to Concepts. In this video, I will discuss the concept of phase shift as well as a brief introduction to time shift, but a detailed relationship between phase shift and time shift will be discussed in a separate video. So to understand the concept of phase shift, I'm going to use sinusoidal functions. So we have here the blue waveform, which is a sinusoidal function, which is a cosine function, cosine omega t, and we can write it as cosine 2 pi ft. And the red waveform that we have at the bottom is a sine function, which is sine omega t, which can be written as sine 2 pi ft. So since omega is equal to 2 pi f, so omega equals, so let me write it here, omega equals 2 pi f. So f is the frequency of the signal in hertz and omega is the frequency in radians per second. So the concept of phase shift is basically the shifting of the waveform either to the left or to the right. And if you notice that the blue waveform, when shifted to the right by a certain amount, becomes the same as the red waveform, that is the cosine shifted to the right by a certain amount becomes the sine waveform. So the first thing I want to emphasize here is that a shift to the right, shift right, corresponds to a shift by a negative angle. So that means shift right means cosine omega t minus some angle theta. So when this sign is negative, then the waveform is shifted to the right. Similarly, a shift to the left will correspond to cosine omega t plus theta, and the same applies to the sine as well. So shift to the right would be sine omega t minus theta, and shift to the left would be sine omega t plus theta. So the first thing we need to remember is that shift by a negative angle corresponds to the waveform being shifted to the right by that angle theta, and when the waveform is shifted by a positive angle, it corresponds to the waveform being shifted towards the left by the angle theta. The next thing I want to highlight here is that the sine function, or the sine signal sine omega t, can be obtained by shifting the cosine function to the right. So we'll shift the cosine function to the right, that means by a negative angle, and the amount of shift that needs to be done, or the value of theta that should be used to shift the cosine to the right and make it as the same as sine, is 90 degrees. So when the cosine waveform is shifted to the right by 90 degrees, we get a sine waveform. So we can write this in terms of pi as cosine omega t minus pi by 2. So to illustrate this, let's look at some videographic illustration. So the waveform, the green waveform at the top here, is the cosine waveform, so that's cosine omega t, and at the bottom we have the sine waveform, which is sine omega t. So the first shift that we saw here, so we're going to shift the cosine waveform to the right in steps of 45 degrees. So we have a 45 degree shift already here, and then now we have a 90-degree shift, which has made the cosine waveform, the green waveform, the same as the black waveform. So if we go back to the point where the green waveform is the same as the black waveform, that's a shift of 90 degrees. So when we started from the cosine, that's a shift of 45 degrees, and that's a shift of 90 degrees. And when the cosine waveform has been shifted to the right by 90 degrees, it becomes the same as the sine waveform. So the sine omega t is nothing but cosine omega t. Shifted to the right means minus, and the amount of shift is 90 degrees. A further shift of 45, and then a further shift of 45 degrees, that makes it a total 180 degrees phase shift. So when the cosine waveform is shifted to the right by 90 degrees twice, that is 180 degrees, it becomes an inverted cosine waveform. So the cosine waveform had a peak here at the top, and when it is shifted by 45 degrees and then 90 degrees and then 135 degrees and then by 180 degrees, the cosine waveform becomes a negative cosine. That is, when we shift the cosine waveform, cosine omega t minus 180 degrees, which is cosine omega t minus pi, we get minus cosine omega t. So that's a negative cosine. So basically the negative sign can be compensated by including a phase of pi in the angle of 180 degrees. One of the things we need to remember is when the shift is equal to pi, whether we shift it to the right or to the left, in both cases the waveform will become the same. For example, so that's a minus cosine at the moment. The green waveform at the top is a minus cosine. So if we had to shift this to the right from minus cosine, if we shift it to the right, it becomes plus cosine, so it's the normal cosine wave. If we shift it to the left by 180, it once again becomes also cosine. So whether we shift it to the right or to the left, it becomes the same. So minus cosine omega t, so we can get rid of that negative sign in front by including a phase shift of 180 degrees, and that phase shift could be either to the left or to the right. So that could be either minus pi, which is also equal to cosine omega t, plus pi. So in both cases it would mean the same thing. So a phase shift could also be interpreted or looked at as a time shift, where the waveform is being either delayed in time or advanced in time. So there is a relationship between the phase delay and the time delay. We will discuss this relationship in our next video, where I will highlight the exact relationship between phase shift and time shift. So phase shift is related to time shift. So that means the waveform may be advanced or delayed.